How do we find planets that we can't see? Well, there are multiple ways, but in this video, we're specifically going to talk about radial velocity. I'm your galaxy guide, and let's get into it. When a planet orbits a star, it causes the star to slightly wobble. This means that the star isn't going to sit in the exact same position, it's going to end up moving slightly towards us and slightly away from us. This motion affects starlight by causing the spectrum to shift. What I mean by this is when it moves towards us, it's going to get blue shifted, and when it moves away from us, it's going to get red shifted. The pattern of shift can be measured using a spectrograph, which is the method of splitting the light into all of its component colors. This method can be either called the Doppler spectroscopy or the radial velocity method. A famous example is 51 Pegasus b, which was the first exoplanet found orbiting a sun-like star using this technique. Since it was relatively close and quite massive, the gravitational pull of the planet caused a noticeable wobble in the star, making the shift in the star's spectrum easier to detect. When plotted over time, the shifts form a sinusoidal graph, a smooth, repeating up and down pattern. This reflects the consistent movement of the star moving towards and away from us. Planets with shorter orbital periods are actually easier to detect because they wobble more frequently, whereas planets with longer orbital periods require longer observational times to capture that full cycle. Even a single measurement can provide information, but for accuracy, astronomers try to observe the star for the entire orbital period. The radial velocity method is just one of many ways to figure out whether a planet exists out there.